CSIR JRF Net Physics. And this is class number N17, questions based on nuclear physics, nuclear force. Nuclear force MCQ. Net class. CSIR JRF Net Physical Science. And here is the first question from nuclear force. The strong nuclear force between a neutron and a proton in a zero orbital angular momentum state denoted by FNPR, neutron proton, NPR, FNPR, where R is the separation between them. Similarly, FNNR and FPPR denote the force between a pair of neutrons and protons respectively, a zero orbital momentum state. Which of the following is the correct option for internucleon? Which of the following is the correct statement if the internucleon distance is 0.2 Fermi, 50 Fermi or less, 0.2 F or less? You look here. The strong nuclear force between a neutron and a proton in a zero orbital angular momentum state is denoted by FNPR, where R is the separation between them. Similarly, FNNR and FPPR denote the force between a pair of neutrons and a pair of protons respectively. Zero potential momentum state. In the zero potential momentum state, which of the following options is correct? Which of the following is correct if the internucleon distance is 0.2 Fermi or less? 0.2 Fermi or less എന്നുള്ളത് എഴുതി ചേർക്കുക. പിന്നെ which of the following is correct അത് എഴുതി ചേർക്കുക. അത് മിസ് ചെയ്തതാണ്. The answer is FNB is attractive for triplet spin state and FNN and FPP are always repulsive. Number B, FNN and FNB are always attractive and FPP is repulsive in the triplet spin state. FPP and FPP and NP are always attractive and FNN is always repulsive. Number 3, all three forces always attractive. These are the 4 choices and the correct choice is B. Correct choice is B, that is FNN and FNP are always attractive and FPP is repulsive. That is the correct answer, and an explanation for the same is given here. A solution: inside the nucleus, the interaction between neutron and proton, neutron-proton. You put a hyphen. Inside the nucleus, the interaction between neutron-neutron and neutron, spelling you correct. Neutron, N-E-U-T-R-O-N. Neutron-proton is always attractive due to nuclear force, whereas between proton is repulsive due to Coulombic interaction. Coulombic, C-O-U-L-O-M-B, I-C, C-O-U-L-O-M-B, I-C, Coulombic interaction. Thus, FNN and FNB are always attractive and FPP is repulsive. The answer itself is explained. The choice itself is explained and there is no other calculation shown. Next question, a negative muon, meson, a negative meson, which has a mass nearly 200 times that of an electron replaces an electron in a Li atom, lithium atom. The lowest ionization energy for the muonic lithium atom is approximately a negative muon which has a mass nearly 200 times that of an electron. That of an electron replaces an electron in a lithium atom. The Lowest ionization energy for the muonic Li atom is approximately same as that of helium, same as that of helium, same as that of a normal lithium, 200 times, 200 times larger than that of a normal lithium, the same as that of normal beryllium, B. The answer given is C. Answer is C. That is, answer is 200 times larger than that of normal lithium. A calculation is given here. Ionization energy I is equal to R element. R element R infinity by N. This Rydberg constant. Z minus S square into M dash by ME, which gives ionization energy I is equal to A into M dash by ME. For normal lithium atom, M dash, that is reduced mass. Reduced mass we calculate by the equation M1 M2 by M1 plus M2. Reduced mass we calculate by the equation M1 M2 by M1 plus M2. For lithium, the mass is equal to, the atomic mass is equal to 7 times the mass of proton, MB. And then there is M electron by 7MB plus ME, which gives 1, nearly 1. The answer is nearly 1. Because in the denominator, ME can be neglected. And I lithium, we find for muonic lithium atom M dash is 7MB plus MU by 7MB 7MB into MU by 7MB plus MU. In the denominator, you have to put plus. It is reduced mass, and that is shown correctly in the calculation. 7 into 1836. 1836 into 200 electron, Me square, by, that is, proton mass is 1830 times of electron mass, and muon mass is 200 times the electron mass. That is written there. And there is a Me square. Me square is not Me into Me square, it is correct. By 7 into 1830 plus 200 Me will cancel. In the denominator it is Me square. In the numerator it is Me square. In the denominator it is Me. Me will cancel if we get 197 Me. So ionization energy of lithium is equal to 197 A. That is 197 ILI. The correct option is C. Answer does not match. There is a slight difference of 3. So you can choose answer as C. Next question. A proton moves with a speed of 300 meters per second in a circular orbit. In the XY plane, plane in a magnetic field 1 Tesla along the positive Z direction. When an electric field of 1 volt per meter is applied along the positive Y direction, the center of the circular orbit remains stationary, moves at 1 meter per second along the negative X direction, moves at 1 meter per second along the positive Z direction, moves at 1 meter per second along the positive X direction. You see the question once again. A proton moves with the speed of 300 meters per second in a circular orbit in the XY plane in a magnetic field 1 Tesla along the positive Z direction. When an electric field 1 volt per meter is applied along the positive Y direction, the center of the circular orbit A remains stationary, B moves at 1 meter per second along the 1 meter per second along the negative X direction. Number C is moves at 1 meter per second along the positive Z direction, moves at 1 meter per second along the positive x direction? The answer is D. That is moves at 1 meter per second along the positive x direction. So the three directions are shown in the figure. V is the velocity and B is the field direction which is shown in the Z axis. We have to find the motion direction. Charge particle, not a change. Charge particle will deflect in the positive x direction with the V is E by B. Velocity of a charged particle in a combined electric field E and B is given by V is E by B. That is 1 by 1 meter per second. That is the answer. Next question. The electric field, the electric and magnetic fields in the charge-free region Z greater than 0 are given by E is equal to E0 e raised to minus k1 Z cos k2x minus omega t j. And the B field is E0 by omega e raised to minus k1 Z into k1 sin k2x minus omega t I plus k2 cos k2x minus omega t into k, where omega, k1 and k2 are omega, k1 and k2 are positive constants. The average energy flow in the x direction is A E0 square k2 by 2 mu 0 omega e raised to minus 2 k1 Z. B E0 square k2 by mu 0 omega e raised to minus 2 k1 Z. C E0 square k1 by 2 mu 0 omega e raised to minus 2 k1 Z. 1 by 2 C epsilon 0 E0 square e raised to minus 2 k1 Z. Answer A. And it has a answer A. It has a small calculation, and the calculation is given here. The total energy flow, energy flow per unit area in a combined field is represented by the points vector. Points vector, S vector is equal to not a plus. S vector is equal to 1 by mu 0 E cross B. If we write in terms of E and H, we can simply write E cross H. So when B field is given, the points vector is equal to 1 by mu 0 E cross B. B field is given. The two fields are multiplied. When we multiply the two fields, we get as in the expression given here. And there is a theta term put. Theta is k2x minus omega t. So points vector, we further simplify, we find its magnitude. Its magnitude is found to be E0 square k2 by 2 mu 0 omega into e raised to minus 2 k1 Z. Next question. A uniform magnetic field in the positive Z direction passes through a circular wire loop of radius 1 centimeter and resistance 1 ohm lying in the xy plane. The field strength is reduced from 10 Tesla to 9 Tesla in 1 second. The charge transferred across any point in the wire is approximately. A uniform magnetic field in the positive Z direction passes through a circular wire loop of radius 1 centimeter and resistance 1 ohm lying in the positive xy plane. The field strength is reduced from 10 Tesla to 9 Tesla in 1 second. The charge transferred across the point in the wire is approximately A 3.1 into 10 raised to minus 4 coulomb, B 3.4 into 10 raised to minus 4 coulomb, C 4.2 into 10 raised to minus 4 coulomb, 5.2 into 10 raised to minus 4 coulomb. Answer is C. That is 3.1 into 10 raised to minus 4 coulomb. And it has a calculation, and that is Faraday's law of electromagnetic induction. Induced EMF E is equal to minus d phi by dt. Induced EMF E is equal to or epsilon is equal to minus d phi by dt, which gives E is equal to or epsilon is equal to, but phi we can replace. Phi we can replace in terms of I. I is equal to dq by dt. I is equal to dq by dt. Therefore, dq by dt is equal to E by R. E by R. E by R, in the place of E, we write d phi by dt. So, minus 1 by R d phi by dt. We put the value of E from the first term. From this we get dq is equal to minus A by R dB, area by R into dB. You know, area into dB is d phi. Area is minus pi r square. Area is pi r square. There's a minus sign. Minus pi r square by R dB. Put the values. dq is equal to minus pi 3.14 into r square 10 raised to minus 2 square by 1. That is 3.14 into 10 raised to minus 4 coulomb. COU LOMB. COU LOMB. Or simply capital C you put 4 coulomb. Next question. The half space region S greater than 0 and x less than 0 are filled with dielectric media of dielectric constants epsilon 1 and epsilon 2 respectively. There is a uniform electric field in each part. In the right half, the electric field makes an angle theta 1 to the interface. Corresponding angle theta 2 in the left part satisfies the relation. You look here, the half space region x greater than 0 and x less than 0 are filled with dielectric media of dielectric constants epsilon 1 and epsilon 2. Respectively, there is a uniform electric field in each part in the right half. The electric field makes an angle theta to the interface. The corresponding angle theta 2 in the left half satisfies. And this is the figure representing the situation given. That is, at one side there is E1, and other side there is E2. The angles are theta 1 and theta 2 represented. What is the condition they satisfy? You know, this is, here the conditions are given. Epsilon 1 sin theta 2 is equal to epsilon 2 sin theta 1. B, epsilon 1 tan theta 2 is equal to epsilon 2 tan theta 1. C, epsilon 1 tan theta 1 is equal to epsilon 2 tan theta 2. Epsilon 1 sin theta 1 is equal to epsilon 2 sin theta 2. Answer C. Epsilon 1 tan theta 1 is epsilon 2 tan theta 2. And here there is some calculation given. You do not necessarily read this calculation. You have studied this relation in your magnetic field. You know, the boundary conditions. The boundary condition for refraction of magnetic field lines, electric field lines in a surface separating two media that you have studied. The boundary condition for refraction of electric field lines in the interface of two dielectric media. It is tan theta 1 by tan theta 2 is equal to epsilon r1 by epsilon r2. That is the relation you have studied theory. And that theory you need not apply here. You know the relation, that is tan theta 1 by tan theta 2 is epsilon r1 by epsilon r2. Epsilon r1 by epsilon r2 can be also written as epsilon 1 by epsilon 2, because epsilon is epsilon r into epsilon 0. When we write as epsilon r1 into epsilon 0 by epsilon r2 into epsilon 0, epsilon 0 will cancel. So tan theta 1 by tan theta 2 is epsilon r1 by epsilon r2, or we can write equal to epsilon 1 by epsilon 2 that you have studied. And when we cross multiply, we get epsilon 1 tan theta 1 is epsilon 2 tan theta 2. This is actually the boundary condition when electric field lines cross over a junction separating two dielectric media. And here a calculation is given that is not required. Just you by heart the relation, because you study this in theory. You know, there are similar relations in magnetic field, in electromagnetic field. In magnetic field, the condition for refraction is tan theta 1 by tan theta 2 is equal to mu 1 by mu 2, or mu r1 by mu r2. where mu R1 and mu R2 are the relative permeabilities of the two media. That is for magnetic field. For electrostatic field, the same relation becomes for refraction as tan theta 1 by tan theta 2 is equal to epsilon 1 by epsilon 2 or epsilon R1 by epsilon R2. That you remember. That is all with your 17th class on nuclear physics. We continue our topic. Thank you very much.